So today we will solve May 2023 question number 19, which is this question has come from the chapters Moment and Work Energy Power, which is a mixed up question. So let's solve this question. In the question they have said the diagram shows a crane lifting a load. So the thing they have said is the diagram shows a crane lifting a load. So this is the load which has been lifted by this crane. There is a large mass called a counterweight. This is a counterweight given to balance this beam, so that when the load is been lifted, this doesn't fall in right in this position. There is a counterweight given in this position, so in order to balance the weight of the load by this counterweight on the opposite side of the tower to the load. The crane has an electric motor with an efficiency of 47%. We know the formula of efficiency. The formula of efficiency is total power input divided by total power output. We have learned these things from the O levels. So they have said us about the efficiency, and then the crane lifts a load of 4.4 into the force is here is 4.4 into 10 to the power 4 Newton. This is the weight of the load. The load moves through a vertical distance of 15 meter. So it has been moved from 15 meter. And this is the vertical distance, and a time of 70 seconds has been used in order to lift that. They have asked us to find out the average power input. So as we all know, the formula of efficiency is average power output divided by the average input power, or you can say average power input. This is the formula of efficiency. So we have been given we have been asked to find out the average power input. We have to find this, and we have been given the efficiency. We have to just find out average power output and use this efficiency with this average power output in order to find out the average input. We have been given the details in order to find out the average power output right here. So in order to find out the power, we know the formula of power is equal to, we know the formula of power is equal to work done divided by time. So we know the time is 70 seconds given, but we have to find out this work done. So the work done will be force into distance. We know the force, and we have been also given the distance, which will be 4.4 into 10 to the power 4 Newton into this distance of 15 meter. So the work done will be 6.6 into 10 to the power 5 joule. So we will use this work done right here. And the power will be, this is the total power output power, which we have put 9.4 into 10 to the power 3 watt. And now we will put this output power right here to find out this average input power. So we know efficiency equal to total output power divided by average power input. So we know the efficiency has been given as 47%, which will be 47 is equal to average output power. We have found this 9.4 into 10 to the power 3 watt, and we have to find out the average power input. By cross multiplying this, the answer will be 2 into 10 to the power 4 watt. Not writing it again, as you are in AS, you have to be able to find out this average power input from these two. That's 2.4 into 10 to the power 4 watt. So let's move forward and answer question number 19b. In 19b they have said the horizontal distance from the load to the tower can be changed. This distance from the load to the tower can be changed, means this load can be taken into this position or into this position. In either position, it can also be taken into this position, this load. And the horizontal distance from the counterweight to the tower as can also be changed. So this the distance of this 8 meter from the tower can also be changed. The counterweight can be bring into right here. Okay. Explain how the counterweight needs to move when the load is moved away from the tower. So the thing that they have said is right here is, if the load is moved in this position, why will be this counter move need to be move in this position? If the counterweight, why the counterweight needs to move when the load is moved away from the tower? If this load is moved away from the tower, then why this counterweight will also have to move? The reason behind that is, we know the total clockwise moment. We know total clockwise moment is equal to total anti-clockwise moment. So this is our clockwise moment and this is our anti-clockwise moment. And there is a beam as well which has a center of gravity. This beam has a weight of this whole beam. This is the center of gravity, or this is the center of gravity actually. So it has a weight as well, and this load has also a weight. These are all the weight that is acting in total clockwise moment, and this is all the weight that is acting on the total anti-clockwise moment. If we know the total clockwise moment, the formula of moment is force into distance. If the load is moved in this position, the distance will increase. As the distance will increase, the moment will also increase. So the total clockwise moment will increase. So in order for the moment to be equal, for the total clockwise moment will also need to increase. Along with, as the total clockwise moment is increasing, the total anti-clockwise moment will also need to increase. The weight of the counterweight cannot increase, so the force will not be able to increase. So the distance needs to be increased. So this total anti-clockwise moment needs to be equal to this total clockwise moment. And for this total anti-clockwise moment to be equal to this total clockwise moment, when it has increased its distance and the total clockwise moment has increased, so this total anti-clockwise moment needs to also increase by increasing the distance, and the distance will be increased of the counterweight. So let's write it in the way that Marskem have asked us to write. We have made you understand. Now we will write the answer. The answer will be in this way. The total clockwise moment must balance total anti-clockwise moment about tower. This is our answer 1. So that as the resultant moment must be 0. the total, this is the anti-clockwise moment and this is the clockwise moment. The clockwise moment is because of the load and the weight of the beam, and the total anti-clockwise moment is because of the weight of the counterweight. Okay, right, let's write it down. Total clockwise moment is due to sum of moment from the beam and the load. The total anti-clockwise moment is due to the counterweight. So right now we will write the main answer. This was, we have gained 2 marks by writing all those things. Now we will write the another 2 marks, the rest of the marks. If we increase the distance of the load, the clockwise moment will increase. So to balance the clockwise moment, anti-clockwise moment will increase by increasing the distance of the weight of the counterweight. So we are done. These are all the 4 points for overall 4 marks. So let's move to the question number C. And the question number C, they have said the beam is uniform with the weight of this, the counterweight has a weight and the load has a weight. Deduce whether the load can be moved to the end of the beam without the crane toppling. So the thing they have said is, they have given us, in the question they have given us the weight of the counterweight, weight of the whole beam, as we all know, this is the whole beam, this is the center of gravity of the beam, it is the middle point. The whole beam is 30 meter, so this will be 30 divided by 2 equal to 15 meter. So this will be overall 15 meter. As this is 8 meter, so this distance will be 7 meter. So the distance of the beam from the tower will be 7 meter. And the distance of the load needs to be found out, whether this distance can be taken into this position. If the distance of the, if the load is taken into this position, will this topple, will this beam topple or not, will this beam fail or not, fall or not. We have know the counterweight, weight of the counterweight and the distance of the counterweight. This is our anti-clockwise moment, and this, the moment of the beam and the moment of the load is our clockwise moment, and this is our anti-clockwise moment. And for this beam not to topple, if for this beam not to topple, this clockwise moment and anti-clockwise moment must be equal, which means equilibrium. And equilibrium means forces are balanced. If we found out, we know the weight and distance of this counterweight. We know the weight and distance of this pivot. We just know the weight. We know the weight of the load, but we don't know up to how much distance this load can go, and the force will be balanced up to that. We have to find out that distance, and if that distance is equal to, this is 8 meter and this is 30 meter, so overall it has 22 meter. If the distance is greater than 22 meter, then the load can get till the end of the beam. But if it is less than 22 meter, then the load cannot go till the edge of the beam. If the load cannot get to the edge of the beam, then the counterweight will topple. So let's find out the distance up to which this load can go. We have to write in such a manner that we have to find out the equilibrium steps. When it is in equilibrium, the total clockwise moment is equal to total anti-clockwise moment. For equilibrium, this is the weight of the beam and this is the weight of the load, which were clockwise moment. Clockwise moment is equal to anti-clockwise moment. So this weight into its distance, which will be 3 into 10 to the power 4 Newton into the distance, this 7 meter from the tower of this beam, which will be 7 meter plus this load, which is 4.4 into 10 to the power 4 Newton into, we don't know the distance is x, and we know the weight of the counterweight, which is 1.1 into 10 to the power 5 Newton into the distance was 8 meter. This was the distance, right, which was 8 meter. So if we find this x, we have to find out this x. So this x will be 1.1 into 10 to the power 5 into 8 minus 3 to 10 to the power 4 into 7 divided by 4.4 into 10 to the power 4 Newton, which will be equals to 15.2 meter. So this is the distance up to which this load can go, and the equilibrium will be, and the forces will be in equilibrium. So this load can go up to 15.2 meter. It cannot go out any further from this 15.2 meter from the tower. It can go till 15.2 meter from the tower. Up to that, the forces will be in equilibrium. The forces will be in balanced. So if the load crosses this 15.2 meter, then this beam will topple. This beam will fall. So let's find out the distance of this position. If we see here, this load, this is 30 meter. So this is 8 meter. So the distance of this load is 30 minus, the distance of this load is 30 minus 8 equal to 22 meter. So the edge of the beam is at 22 meter. So it is 15.2. So it cannot go till the edge of the beam. If it gets till the edge of the beam will fall or it will topple. So let's go and write it down. This 15.2 is greater than 20 meter. So the crane will topple if the load moved to the end of the beam. So we are done with question number 19. Thank you.